Assalamualaikum warahmatullahi ta'ala wabarakatuh and good AM. So, I'm Said G. Macalaw, the reporter of Rotation about Fixed Axis. So, first, what is fixed axis or rotation about a fixed axis? So, it is a special case of rotational motion. The fixed axis hypothesis includes the possibility of an exchanging its orientation and cannot describe such phenomena such wobbling or precession. Yes, that's it. So angular position. So we can see the color blue, you have R, then how do we say line is with the respected to the purple line? For that, we can use the angle represented by an theta symbol times angular position. So we can show the angular position of R measured from the references of line theta. So next is the angular velocity. It is the derivative of angular position with respect to time. In other words, it is a change of angle over time. So we can show the angular velocity using the Greek letter omega, and it is usually measured in rads per second. So for example, we have this spinning and it has an angular velocity of 5 rads per second. Yes. Then next is angular acceleration. So angular acceleration, thus the derivative of angular velocity with respected time. So we can show angular acceleration using the Greek letter alpha. So if we have a question for acceleration, we can use this equation. Yes, we have the velocity. So it is important to realize that when we say velocity, we are talking about the angular velocity, or in other words, linear velocity, and also called magnitude of velocity. So measured meters per second, if we have position vector from point O to A and multiplied by angular velocity. So we can get the magnitude of velocity and we can represent that using this equation. Yes. So now if we look at acceleration and we want to find the tangential of normal acceleration at point A, so we can use this equation. So for tangential, we'll multiply the angular acceleration by the distance r, and for normal acceleration, we're multiplying the angular velocity squared by distance r. And when it's Cartesian vector form, we can find the normal tangential acceleration using this equation. Yes, this is gear ratios. So we mentioned when we have the two gears with two different sizes. That means we one spin at the certain grade, the other spins at different grade, and how can we relate them together? So we can do so by the ratio of each gear and their respective position. So velocity of acceleration, so we can use this following equation. So yes, in other problem examples, revolution to radians. So in some problems, instead of rads per second, we're given values in revolution. So we might say spins 5 revolution. So remember that 1 revolution is equal to 2 pi rad. So if we have 5 revolution and 2 pi times 5 revolution is equals to 5 10 rad 10 pi rad, I mean, sorry. So yes, so we move in our example. Okay, so in this example we need to find the magnitude of velocity and the normal tangential component of acceleration of point A. Then first we will find the magnitude of velocity, and to do that we need to figure out the angle of velocity. So in this question we're given the angular, so yes, so let's solve it. So first again, remember this is an angular velocity, not the magnitude of velocity. And to find the magnitude, we use this equation. So let's plug it in. The value we know solving give us the magnitude of velocity. And now we need to find the normal tangential of acceleration. First, let's figure it out. The angular acceleration of t over seconds. So we will plug in the equation we're given to us. So and now we know the angular acceleration, we can find the tangential and normal components. And for tangential acceleration, yes, so remember we use the acceleration for that for normal acceleration. So we can use the angular velocity, and all we need to do is use all of this equation and plug one the values in. Yes, then remember we're still looking at the point A, so the distance from center point A is 0. Then point A, I mean center point A is 0.5 meters. Then first tangential acceleration, now the normal acceleration. Remember to use the angular velocity. So we found it. So that's the answer. Yes.